Hello, everyone. So we're Team Logic Legends, and this is our final Disassembler project by Keys, Hamza, and Samar. So let's get started with our project overview. So our program mainly features three aspects. So the first one is interactive user interface. The second is a disassembler program, and then we have screen-by-screen display. So the interactive user interface displays welcome messages and prompts the user to enter necessary input into the program. And then we have the disassembler program that converts memory images of instruction and data back to assembly code instructions. And it does it so by utilizing a custom disassembler algorithm without using any kind of trap function. And then we have a screen-by-screen display, which basically displays one screen of disassembled instructions at a time. Then the user can press enter to view the next screen of information. And as you can see on the right-hand side of the screen, we have a flowchart of our disassembler program. So we have tried to modularize the program by separating the flowchart into small sections and assigning one or more members to focus on each section. So the first thing to do is to get the user input. And to get the correct user input, the program must go through a series of requirements for both starting and ending addresses. And after getting all the inputs from the user, the program will do a final check, which requires the ending address to be greater than the starting address. And after that, the program will enter the disassembling loop, which will read all of the machine codes and then display them to the console. As the program runs, the disassembling loop will continue until the program reaches the ending address. Then it is up to the user to whether they want to restart the program or exit the program. So the next we have is the list of opcodes and all the effective addressing modes that we have implemented and utilized in our program. So for opcodes, we decided to group them based on common bits so that the comparison can be easier and simple. So first we take the 4 bits of the word address and compare that to the current opcodes for bits. And if they're not valid, then we move on to the next opcode. And if there's a match, then we continue to read the next bits through bitmask and then handle each case separately. And for addressing modes, we made a subroutine that classifies each addressing mode given instead of the mode, whether it's a destination or a source, as well as the opcode word. In the case of invalid instruction, we print out the given data in the required format as mentioned in the specification of the project. So as for works completed, we have been able to complete all of the work beginning from designing, implementing, and documenting all of our work. We have also completed our final deliverables for the project. And as for uncompleted work, we have completed most of our work except for the confidential evaluation report that we have to submit individually. And yeah, next Hamza will explain about the software bugs and challenges we faced during our program implementation.
Thanks, Samar. Since this project was like a big project and we've been working on for like since the course started, we've been facing different challenges when we were coding on opcodes. Sometimes we had some challenges to move M, add A, add Q, sub LE, and since we were working as a team, we came together and we were fixing each other. Actually, some challenges was easy, some challenges seemed so hard. The things that seem like a hard challenge was like move M. For example, move M, when we were like doing the coding section of move M, it shows the data. However, it doesn't show and identify the issue, like the movement displays opcode, but it doesn't show the operand. So as the picture demonstrated in the first picture shows that movem is not displaying the operand, like movem that w movem that l. However, when we read the book, when we review the lectures as well as the videos, we come across some kind of solution to face this problem. And then as the second picture shows, we able to identify the operand on the move m, like move. So the other challenges and that we face, it was like we were trying to display the address of the branch. However, we can able to display the address and the branch, but we cannot able to display the value. And these are the two challenges that we came across, and seems we cannot able to have a solution right now. But if we get more time, we can come up to solution to fix move m, as well as displaying the value of a the branch. I can transfer to Ahmed to show how our code performs the requirement is that being expected, and that's it. Ahmed, you can do.
Okay, so as you can see my screen, this is our code. So let me run it. We don't have any errors, any problems. As you can see, we have a welcome message to our decoder. And we also have a starting address, memory address, and let me put the starting memory address for where our code is starting from. So I believe our decoder will start. Let us say our decoder started from, let's say here. So let me put that address 00. Let me put that as 0000. 3228. 3228. And then our program will show us the ending address. And let me put the last address somewhere here. So let me put it 00377E for capital. The program will make sure that the starting address is greater than, the ending address is greater than the starting address, and it will display the data. So from here, as you can see, we have illegal instructions. Those addresses is one of the opcode that we don't supposed to translate. So here is the memory location. This is our opcode, and this is our operand. So our program is working fine. If I click enter, it is shown as a page. So it's like 25 line of codes. So it's shown as like move P for opcode and stuff like that. So that's our code, and everything's working fine other than move M. Thank you so much.